Hi, welcome to a ramble with me. Today we are busy with, slowly, no, not slowly, almost right at the end of paper 1 of November 2022 from the department. And today we're looking at question 10.1. A, B, and C are three events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. Okay, so let's just get familiar with the Venn diagram before we dive into the questions. This 0,05 is the probability of only A happening, right? This bit does not intersect with anything. This 0,15 is the probability of A and C happening but not B, right? If we wanted to include B, then the probability of that happening would be X, right? And the 0,15 and plus X is the probability of A and C happening, immaterial of whether B happens or not as well. So cool. And then the rest of the interpretations are pretty similar, just looking at different pairs of events. So for example, the 0,2 here would be the probability of B and C happening but not A. But if you wanted the probability of B and C happening, whether A happens or not as well, then that would be this whole chunk over here, 0,2 plus X. Then the other interesting one is this one out here. Y is the probability of none of the events happening. Okay, cool. So let's see what the first question asks. If it is given that the probability that at least one of the events will occur is 0,893, calculate the value of Y. Okay, so 0,893 is the probability of this whole blob here. At least one of the events occurs means we are finding ourselves in one of these spots here. Remember, this is the spot where none of the events occur. And at least one of the events occurring is the opposite of none of them occurring. So this is a complement situation. So Y will be equal to 1 minus 0,893, which is equal to 0,107. Okay, right, so we now have the value for Y. Okay, and then X, the probability that all three events will occur. Okay, so we can find that by saying that, well, when all of these are added up, they should add up to 0,893. Or when everything in the Venn diagram is added up, it should add up to 1. So I am definitely not going to write, I am going to write all of it out. So X will be equal to 0,893 minus all the other stuff, 0,05 plus 0,15 plus 0, what am I doing? Plus 0,05, okay, so I got that one, 0,1, 0,2, and the last one, 0,183. Okay, and of course I'm not going to use a calculator because why would I make my life so easy? So the 0,2, 0,25, 0,35, 0,55, and then 0,733, I think. Right? 0,55, 0,183, so that's 337. Yeah. Okay, and if we subtract those, we get 0,16. So that would be the probability that all three events occur. Okay, let's see how we're doing so far. We have, oh my word, did I miss a question? Sorry, I'm just realizing from a previous video I might have missed a question. Wah, 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 wah. Yeah, I might need to go back and record the rest of, anyway. So right, we have y. Okay, so the first one went well, we agree. Okay, Kalki, we agree, cool. And then the next one we also agree. Okay, cool. So on to the next. So we know that x is equal to 0, 16 and y is equal to 0, 107. Right. Determine the probability that at least 2 of the events will take place. Okay. So at least 2 events taking place is this space, that space, and this space, right? Because this is A and C happening but not B. This is all 3 happening. This is B and C happening but not A, and this is A and B happening but not C, right? These are the places where only one event is happening, and this is where none are happening. So we're just gonna add 0, 15 plus 0, 1 plus 0, 2 plus 0, 16, which is 0, 61. Right? Yes. Yeah, on a roll. And then the last question, well, first let's write off what we know. Okay. Are events B and C independent? Okay, so remember, if B and C are independent, then the probability of B times the probability of C will be equal to the probability of B and C happening. So let's see what we get. So we'll first work out the probability of B times the probability of C. Okay, so the probability of B is the sum of all of these guys. Okay, so that will be 0, 1 plus 0, 16 plus 0, 2 plus 0, 183. And we are timesing that with the probability of C. And that is going to be all of these guys. Okay, so that is 0, 2 plus 0, 16 plus 0, 15 plus 0, 05. Okay, and let's just simplify all of that a little bit. So that is, in our first bracket we have 0, 26, 0, 46, 0, 643 times, second bracket is 0, 56. Okay, and then definitely don't have the brain power to work that out. So that's 0, 36008. Okay, and then the probability of B and C, that is going to be B and C is here. Okay, so that is 0, 2 plus x, which is 0, 36. So this is interesting because I am not actually sure what the answer is going to be in the memo, but I think that in the real world these two are so close to each other that we would say that B and C are in fact independent, because they might not be exactly equal, but they're so close to each other. So B and C are pretty much independent. But strictly speaking, they are not exactly equal. So, the memo might say B and C are not independent. So I don't know. I am not going to commit to an answer. I am just going to see what the memo says and back it. So let's see. That's if my numbers are even right, honestly. So they say they are independent because the products are equal. So yeah, I think that if I had to commit to an answer in an exam, I would say um, they're so close to equal that we can really just say B and C are independent. But I don't think I'd be so bold to say they are exactly equal. Anyway, let me go and finish recording the video for the other question that I didn't complete. Cool. See you another time for another chat.